In this lecture, we will see what is the drawback of the duobinary coding system and what is the use of precoding in a duobinary coded sequence. What use of precoding? So we already know in a duobinary coded system, we know how to code the signal. The duobinary coded output CK is actually given by AK plus AK minus 1, where AK is our palm signal. Okay, so if this is the case, how will you detect AK at your output? So at the detector, in order to detect AK, what you have to do is AK will be CK minus AK minus 1, is it? So at the detector, your detector output AK estimate will be CK minus AK minus 1 estimate. Okay, so what here it do is, in order to get a output at the instant K, I have to consider the previous estimate. This AK minus 1 is my previous estimate. So this technique is known as decision feedback. So this is actually the major drawback of this duobinary encoding system. So here you see, if I make an estimate, previous estimate was an error, what happens? My present estimate will also tends to be error. So this will result in an erroneous output of the coming estimate also. Okay, so that means a decision on the current input actually depends upon the decision on the previous input. So this result in the propagation of error throughout the system. So this is a major drawback of the duobinary coding. That is, we are just adding these two. So this will result in an error. So in order to overcome that, we will be using a pre-coding before the duobinary coding. So in this session, we will see what is a pre-coding. So in pre-coding, actually we are doing the pre-coding on the original binary sequence BK. Okay, so our binary sequence is 0 and 1. Pre-coding is performed on the original binary sequence. So what it do is, it converts into another binary sequence. Again, it is a binary sequence DK, where DK is given as BK exclusive or BK minus 1. So this operation is also known as modulo 2 addition or exclusive OR operation. Okay. So you can see the figure. So this is a block diagram for a precoder. So I have the input binary sequence. So this will take, this is my BK, this will take either value 0 or 1, and this is my precoder. This block represents my precoder. So my precoder output BK will be actually equal to original binary sequence exclusive OR, then the DK minus 1. Okay, so here there is no addition operation. You are doing the exclusive OR operation, exclusive OR DK minus 1. So this is my precoder output. Now what I do is, this precoder output is then applied to the palm system. So you can see the block diagram. So this is the, this one is our pulse amplitude modulation PAM block. So this is my PAM block. So what it do, where my output will be AK. AK will be either 2 levels +1 or -1 as earlier. Then you have the duobinary. So all these are the same as earlier. So its output will be CK. CK will be AK plus AK minus 1. Okay, so only thing is, we have the precoder. That is, precoder is actually applied to the binary sequence. The remaining blocks are the same. So we can see one example for an input binary sequence. So this shows the example. This table shows the input binary sequence. This is my binary sequence. So this input binary sequence may be either taking the value 0 and 1. That is given. Now what we do is, first the binary sequence is given to a precoder. So this is the precoder output. You know, DK equal to BK exclusive of DK minus 1. Okay. Now for the time being, I assume the first bit is 1. I assume it is 1. Okay. So how to find the DK? DK is BK exclusive of DK minus 1. So 1 exclusive of 0. So you'll be having the value 1. What is the condition for exclusive operation? Only for 0 1 or 1 0 you will get the output as 1. Then for 1 1 and 0 0 your output is 0. Okay. Now you consider the next one. For this for output at this instant, what you have to do, bk exclusive of dk minus 1. Similarly, output at this instant is 1 exclusive of 1, that is 0. Put at this instant is 0 exclusive of 0, again 0. Output at this instant is 1 exclusive of 0 is 1. Put at this instant is 1 exclusive of 1, that is 0. Similarly, 0 exclusive of 0, 0. So this is my precoder output. Then it is applied to the pulse amplitude modulator. So similar to earlier, all the ones are encoded by +1. All the zeros are encoded by -1. Wherever I have zeros, zeros are encoded by -1. That is taking only two amplitude +1 and -1. Now it is given to the duobinary encoder. So we know in a duobinary encoder, Ck equal to Ak plus Ak minus 1. So you take for this one, Ak plus Ak minus 1, that is +1 plus 1, 2. Then at this instant, +1 plus 1, 2. Then -1 plus 1, 0. Then at this instant, -1 minus 1 minus 2. Then +1 minus 1, 0. Like that you have the duobinary coded sequence. Then what is a binary sequence? Binary sequence is obtained by applying the decision rule. So here what is a decision is, here you can see, you just compare, you can see for all your sequence, for all corresponding, this is your 0. Okay, so this is a binary input sequence is 0. So just see for all zeros, how is it coded? Zeros is coded by +2 here. Then see here I have 0. 0 is coded by -2. Then again here I have 0. 0 is coded by -2. So you can see all the zeros are coded by either plus or -2. What about 1? Wherever I have 1, all the ones are coded by 0. All the ones are coded by 0. Zeros are coded by plus or -2 and all the ones are coded by 0. So you have Ck is having the value 0 if my binary symbol is 1, and it is taking the value plus or -2 if my binary symbol is 0. So your decision rule, we have to take a threshold. So we take the threshold as 1. Okay. And if my value Ck is less than 1, I take a threshold in between. These two sequence. I take the threshold as 1. Okay. And if I value, that is I take the magnitude. If my magnitude value is less than 1, that means your symbol is Bk is 1. Bk is 1. If my magnitude is greater than 1, I take the magnitude. So if the magnitude is greater than 1, I take the decision in favor of 0. So this is the decision rule. So wherever I have the magnitude greater than 1, I decide in favor of 0. And wherever the magnitude is less than 1, I decide in favor of 1. So this is the decision rule. So this is about the duobinary coding system. So the receiver, the dictator block diagram is shown. You receive the output, that is a receiver is Ck. You first have a rectifier. So you have the Ck here. Then it is given to the decision device. Here the threshold is taken as 1. If the magnitude, actually you are taking the magnitude here. So if the magnitude is greater than 1, if the magnitude of this is less than 1, you decide in favor of 1. If the magnitude is greater than 1, you decide in favor of 0. So the dictator consists of a rectifier and output decision device. Okay. So this is about the precoding technique.